Today we're looking at what a binomial distribution is. A little bit of review from last class, as well as continuing into some more compound distributions or situations where we have at least or at most a given number. So just a little review from last time. A binomial distribution is a repeated experiment where you have two possible outcomes, either success or failure. And the probability for each of those outcomes is fixed from one event to the other. It doesn't depend on the previous outcomes. So sometimes you'll have some questions that are worded quite convolutedly in the sense that you really need to parse out the English. What exactly is the question asking for? So we'll just go through some examples before we begin. If you're given the numbers from 0 to 10, the numbers which are at least 5 include the number 5. Everything that's 5 or larger. The numbers that are at most 3 are all the numbers that are 3 or smaller, including the number 3. So 0, 1, 2, or 3. A number from 2 to 6 inclusive means that we include the endpoints. So that's all the numbers between 2 and 6, including 6 itself. Now let's do some review problems. So let's say an exam is made up of 50 true-false questions, and a student guesses at each question, what's the chance that they'll get exactly 25 questions right? And we kind of expect that they'll get 25 questions right. So there's a 50-50 chance that they get the right answer. And since there's 50 questions, they should get half the questions right. But that doesn't mean they'll always get 25 questions right. It's probably pretty likely that they'll get about 24 questions right, or maybe 26. But chances are they're not just going to get one question right, unless they're really trying to fail. So the chance that a student will get 25 questions right, we can calculate from the formula from last class. That's the total number of questions, choose the number of questions right, the probability that they get them right that many times, probably that they get them wrong that many times. So n represents the total number, and r represents the number of successes. So out of a total of 50 questions, we want to choose 20 of them to be successes. So the chance that the question is correct is a 50-50 chance. We want that 1/2 chance to happen 25 times for 25 questions. The chance that they get the question wrong is a 50-50 chance as well, because it's true or false. So we want that to happen for the rest of the questions. So your two exponents will always add up to the total of trials that you have. So we've got 25 questions correct, 25 questions wrong. And this will give us the total probability. On your graphing calculator, type in 50, math menu, left one, number 3, choose, 25 times 0.5 happening to the power of 25, and the times 0.5 happening to the power of 25. You get a probability of 11.2%. And we can also do this with the binomial PDF function. So you can type in binomial PDF, and the arguments for that are NPX or NPR. So the arguments for the binomial PDF are the total number of trials, total number of questions is 50, the chance of getting it right is 50-50 chance, and the number of questions that we want to see right. So we want to see 25 right questions. So in order to find the binomial PDF function, you can go to your catalog, second 0, and jump down to the B section by pushing the button that has a B right above it, the apps button, and go down to binomial PDF, and we'll type in 50, comma, 1/2, comma, 25, commas right above the 7. And we also get 11.2%. Well, what's the chance that a student gets exactly 20 questions right? So we expect it to be a smaller probability. Most likely they're going to get half the questions right, but there might be a chance that they'll have a really unlucky day and only get 20 of their answers correct. So the chance of getting 20 questions right is, out of 50 total questions, we want to choose 20 of them to be right. So there's a 50-50 chance that we'll get it right. We want that to happen 20 times. There's a 50-50 chance that we'll get a question wrong. If we get 20 questions right, and there's 50 questions on the test, how many questions will we get wrong? 30. So the total probability is 50, math menu, choose 20, 0.5 to the power of 20, 0.5 to the power of 30. There's a 4% chance. And again, we could also do this with the binomial. Binomial PDF, the total number of questions is 50. The chance of getting it right is half. And the total number that we want to get right is 20. So to type that in, I go to my catalog, second 0, jump down to the B's, choose binomial PDF, 50, comma, you could type in 0.5 or you could type in 1/2, half, comma, 20. Enter. Also a 4.1% chance, 4.2. And so we can use a binomial in all sorts of situations. For example, if we're tossing dice. Let's say we take a 6-sided dice and we toss it 10 times. What's the chance that we'll get 2 6s? So we're tossing this dice, and we can get all sorts of possibilities in the 10 rolls. And we want a 6 to pop up 2 times. So think about it. How many times do you have to roll the dice in order to expect to get 2 6s? Well, since there's a 1 in 6 chance of getting a 6, if we roll the dice 12 times, then we should expect to see 2 6s. The expected value for a 6 would be 2 times. But if we only roll the dice 10 times, then we wouldn't always expect to see 2 6s. Maybe we'd expect to see more like 1 6 more often than 2 6s. The expected value is a little bit less than 2 when you're rolling the dice 10 times. Okay, so the probability of getting 2 6s is, out of the total number of times that we roll the dice, we want to get 2 6s. The probability of rolling a 6 to the power of the number of 6s, the probability of not rolling a 6 to the number of not 6s. So we have 10 rolls, and we want 2 of them to be 6. The chance that we get a 6 is a 1 out of 6 chance. We want that to happen 2 times. 1, 2. But that means that we still have 8 other rolls. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 other rolls, and the chance of each of those not being a 6 is 5 out of 6. So the total probability that we're going to get 2 6s out of 10 rolls 10, choose 2. We want the 1 out of 6 chance to happen twice. And we want the 5 out of 6 chance to happen 8 times. So that's a 29% chance. Okay, and we can also do this with the binomial PDF, where out of 10 total trials, with a 1 in 6 chance of getting a 6, we want that to happen twice. So, out of 10 tries, 1 in 6 chance of getting a 6, we want 2 6s, and 29% chance. Now, a hypothetical situation. Suppose at the beginning of this term I said that I'm going to start giving pop quizzes. The chance that you're going to get a quiz on any day is 20%. So what's the chance that out of the next 30 days, I'm going to give you 7 quizzes? So out of a total of 30 days, you're going to get 7 quizzes. So the probability that you get 7 quizzes is, out of the total number of days, you want to choose 7 of those days for a quiz. The chance of getting a quiz is 20%. That's going to happen on 7 days. Chance of not having a quiz then would have to happen on the rest of the days. So if I have 7 quiz days out of 30, that means I'm going to have 23 not quiz days. The chance that you're not going to get a quiz is 80%, exactly the opposite complementary probability of having a quiz. So again, we can calculate this in 2 ways. Doing 30, choose 7, times the 0.2 happening to the power of 7, times the 0.8 happening to the power of 23. There's a 15% chance that you would get 7 quizzes. And again, you can do this with the binomial PDF. Binomial PDF of, out of 30 days, with the probability of getting a quiz at being 20%, we want to get 7 quizzes. So you can also do second enter to get back what you typed instead of always having to go back into the catalog. Then we can just change the values. 30, 0.2, and 7. So there's a 15% chance. And here's where we get to the new stuff. What's the chance that I'll give at least 7 quizzes? So I'll show you 3 ways to solve this problem. At least 7 quizzes. First of all, what we could do is we could add up the chance of having 7 quizzes, or 8 quizzes, or 9 quizzes, or 10 quizzes, all the way up to 30 quizzes. So that would be 30 choose 7. We want 0.2 to happen 7 times, and 0.8 to happen 23 times. Or you could have 8 quizzes. The 0.2 happening 8 times, 0.8 happening the rest of the times. Or 9 quizzes. 0.2 happening 9 times, 0.8 happening 21 times. Or 10 quizzes. 0.2 happening 10 times, 0.8 happening 20 times. Or forever. This is really cumbersome. Can you imagine plugging that all into your calculator all the way up to 30? Too hard. So there's got to be a shortcut. How you can use the binomial PDF. One thing that you can do is you can take your binomial PDF, and if we did 30.2 and 7, that would give us a chance of having exactly 7. If you want at least 7, in squiggly brackets, you can put all the numbers bigger than 7 all the way up to 30. Okay, so what that does, so the squiggly brackets are right above the curvy brackets. So I push yellow curvy bracket, and then I'll type in all the numbers all the way up to 30. And this is kind of time consuming as well, but it's certainly a lot less time consuming than doing all the combinations. And what this will give you in the end is a list of all the probabilities for each of the different values. So close up with the squiggly bracket and then the curly bracket again. So this gives me a list where, and the calculator takes a long time to think about how to do this one. There we go. Where the first one is the chance of getting exactly 7. The second number is a chance of getting exactly 8 quizzes. Third number is a chance of getting exactly 9 quizzes, and so on and so forth. Now all we have to do is add up all those numbers. And there's a function that does that, and it's called the sum function. So if you wanted to, you could put the sum function before all of this stuff, or you can do it after the fact. So to find the sum function, I go to the catalog again, and I jump down to the T section by pushing the number 4. Go up 1, there's sum, and I'll do second negative sign to get this answer from previous, and it'll add up all the possibilities for me. So 39%. Okay, but you might be saying, well, what if I had to add up all the things, what if it was 100 days instead of 30 days? I wouldn't want to type in all the numbers from 7 to 100. There must be an easier way. And there is. And that's the binomial CDF function. It's the cumulative distribution function. And what this one does is it adds up, well, let me give you the basic. The basic arguments are N, P, and R. And what this will do is it'll add all the probabilities from 0 to R. So it'll add up all the numbers from 0 to R for you. This is really nice for finding out what's the chance of having at most 7 quizzes, because it'll add up the chance of 0 and 1 quiz and 2 quizzes and 3 quizzes all the way up to 7. But it's not very helpful for at least 7 quizzes. Okay, so if we used this binomial CDF with 30 and 0.2 and 7, it would add up all the possibilities from 0 to 7. But we don't want 0 to 7. We want 7 to 30. So we can kind of think backwards and use the complement. So all the way up to 30. Instead of adding up from 0 to, or from 7 to 30, adding up all the possibilities from 7 quizzes to 30 quizzes is exactly the opposite of adding up. So this is what we want. We want all the possibilities from 7 quizzes to 30 quizzes. Now the opposite, the ones that we left out, are having 0 quizzes all the way up to 6. So if we take our binomial CDF function, out of a total of 30 days, with a chance of having a quiz at 20%, we want to add up all the probabilities from 0 to 6. This should give us exactly the opposite of what we want. Let's try it out. So you go to your catalog, second 0, push apps to get down to the B section, and we'll choose the cumulative distribution function for the binomial, 30, 0.2, and 6. And that gives us a 61% chance. 61% and 39%, they add up to 100%. So to find out the probability of what we want, instead of the opposite, we'll just do 1 minus the opposite probability, and we get our 39% back again. So 1 minus the opposite probability is our 39%. That's it.